Okay, we're going to take a look at lesson 2 using the number line to model the addition of integers. So on your lesson worksheet, go ahead and answer exercise 1, parts A and B, and then continue the video when you are done. Alright, so you should have exercise 1, parts A and B completed. So let's take a look at this. So suppose you received $10 from your grandmother for your birthday. You spent $4 on snacks. Using addition, how would you write an equation? Well, that would look like 10 plus a negative 4 equals 6. And again, negative 4 needs to be in parentheses because we don't want two signs next to each other. And then how would you model your equation on the number line to show your answer? Either using hops or jumps, or if you've gotten to a straight line vector, as long as you're showing that you go up $10 and then back 4, then that would give you 6. And I think they actually messed up and did 2 extra jumps on this. But the correct answer is 6. All right. So real-world situations can be modeled with equations and represented on the real number line. In this exercise, positive 10 represents the $10 given as a birthday gift because it is a gain, and negative 4 represents the $4 spent on snacks because it is a loss. So gaining $10 and then taking away $4 will give you $6. So let's take a look at example 1 on the lesson worksheet. And for this, we'll go ahead and do this together. All right. So here we are for example 1. Go ahead and move my mouse out of the way. All right, so it says to complete the steps to finding a sum of negative 2 plus 3 by filling in the blanks. Model the number sentence using straight arrows called vectors on the number line below. So let's do this together. So we're going to place the tail of the arrow on negative 2. Or on 0, actually. And we're going to draw the arrow 2 units to the left of 0 and stop at negative 2. And the direction of the arrow is going to be to the left because we're counting down from 0. Then starting the next arrow at the end of the first arrow or at negative 2. We're going to draw the second arrow 3 units to the right since you're counting up from negative 2, and we're going to stop at 1. So how does this look like using vectors? Well, again, starting at 0, we're going to count 2 units to the left, 1, 2. We're going to put our vector heading, which is to the left. And then we're going to start again at negative 2, and we're going to count up 3 units, 1, 2, 3, and put our vector heading to the right. So this first vector is representing negative 2. This next vector is representing 3, and where we stop at, we'll go ahead and circle it, is 1. All right, so let's go ahead and do example 2. So flipping to the next page. Oh, and we actually didn't finish example 1, so let's go ahead and do that first. So we're going to repeat the process from part A for the expression 3 plus a negative 2. So again, we would start at 0. And this time we're going to count 3 to the right. So 1, 2, 3. Whoops, and I went too far. And then we're going to start at 3, and we're going to go back negative 2. 1, 2. So this first vector represents 3. The next vector represents negative 2. And again, we stop at 1. So what can you say about the sum of negative 2 plus 3 and the sum of 3 plus a negative 2? Does the order matter when adding in numbers? Why or why not? Well, the order doesn't matter when adding -2 plus 3 and 3 plus a -2. Okay, so again, I'm answering the question using the question. The value of each is equal to 1. Therefore, the order doesn't matter. All right, so that is the first example. Now let's go ahead and get to the second example. So this is expressing absolute value as the length of an arrow on a number line. So how does absolute value determine the arrow length for -2? Well, what is the distance from 0 to -2? Well, the distance is 2. Okay? How does the absolute value determine the arrow length for 3? And again, if we start at 0 and we go to 3, the distance is 3. So whether it's 2 to the right or 2 to the left, in this case, the length is still going to be 2. It's just now what direction from 0 are we at. Now, how does absolute value help you represent -10 on a number line? Well, again, it's all about length. So the absolute value of -10 is a line segment with a length of 10. Okay. The fact that it is negative just tells the direction from 0. All right. Let's see if there's any other questions. Yep. Nope, that's it. Okay, so let's go ahead and flip back. All right, so now that we've done that, on your lesson worksheet, complete exercise 2, parts A and B, and then go ahead and continue the video. All right, so you should have for part A, if you are going to represent -6 plus 4 on the number line using vectors, then you would do a vector starting at 0 and going to the left, a length of 6, and then a vector starting at -6 and going to the right, a length of 4. And when you combine those two, you end up, your stopping point is at -2. For part B, you would have a vector length of 3 starting at 0 going to the right, and then starting at 3 going backwards, a length of 8, or not backwards but to the left, a length of 8, and that would stop at -5. All right, so example 3 on your worksheet. Let's go ahead and do that together. It asks to find the sum of the integers represented in the diagram and write an equation to express the sum. So you have an arrow pointing to the right 5, then an arrow pointing to the left -2, and then another arrow pointing to the right 3. So how would you write that? Well, it'd be 5 plus a -2 plus 3, and your stopping point is at 6. So what 3 cards are represented in this model, and how did you know? Well, the cards would be 5, -2, and 3, because the arrows show their lengths, and also what direction. So in what ways does this model differ from the ones we used in Lesson 1? Well, in Lesson 1, a movement of units was shown as 5 separate hops. In this lesson, units are shown as one total movement with a straight arrow, but both represent the same total movement. So instead of hopping, like on a hopscotch, one step at a time, we're just showing one continuous movement from the beginning to the end of the length. So can you make a connection between the sum and where the third arrow ends on the number line? Well, the final position of the third arrow is 6, so that means the sum is 6. So as you concatenate or add each one of those vectors, adding the beginning of the tail to the end of the tip in each one of those, then you end up with your final, the head of the arrow landing on 6. So would the sum change if we change the order in which we add the numbers? For example, if we did -2 plus 3 plus 5. No, because addition is commutative, so the order does not matter. We would still end up at +6. So would the diagram change, and if so, how? Well, our diagram would change because the first arrow would start at and point to left 2 units. Then the second arrow would start at -2 and point to the right 3 units. And then the third arrow would start at 1 and point 5 units right, but it will still end on 6. All right, so let's wrap this up. So how can we use a number line to model and find the sum of -8 plus 5? You should be able to explain that in your own words. And what does the absolute value of a number tell us about the vectors on a number line? All right, and that's it. We'll see you in class.